In this video we're going to look at solving a contextual problem with a normal distribution. So we're told here that there's a machine that creates ball bearings in such a way that the diameter of the balls are normally distributed with a mean of 4.2 millimeters. Over time it is found 5% of the balls have a diameter that exceeds 4.4 millimeters. Find the standard deviation of the diameter of a ball bearing. Well, let's take this wordy problem and let's turn it into statistical language. So let's use x as our distribution. So our distribution is normal. It has a mean of 4.2 and it has an unknown standard deviation because that's what we're required to find. So we can write that in this way. I am told that the probability that a ball bearing exceeds 4.4 is equal to 5%, so 0.05. Find, in this case, sigma, basically. So what are we going to do here? Well, let's do a little sketch. So looking at something being greater than 4.4 is very tiny indeed, 0.05, so that's relating to this kind of probability. So the probability that z exceeding little z is 0.05. So what value of z does that relate to? Well, let's look that up. So that is one that we can look up here. So 0.05 here. So that's 1.6449. So now we know that, we can use the transformation formula. So we know that 4.4 subtract a mean of 4.2 when divided by the standard deviation gives us 1.6449. And from there we can get the fact that sigma is going to be equal to 0.2 divided by 1.6449. So I actually get a very minute value here, 0.122. Let's do it to 3 significant figures as my value for my standard deviation. And if we think about the context of this problem, looking at the deviation from the mean of a ball bearing, actually we would expect a very small standard deviation there. So B, the ball bearing is, the ball bearings are rejected if the diameter is more than 1 millimeter from the mean. What percentage of ball bearings are rejected? So let's have a look at this. We now know that we have this normal distribution with mean 4.2, and we know now the standard deviation is 1.22. We want to know how many of them are more than 1 millimeter from the mean. Well, because this is a symmetrical distribution, if I can find the probability that it is, let's say, less than 4.1, which is 1 millimeter below the mean, this probability is going to be equal to the probability that it's greater than 4.3. So if I can work out this associated probability, then I've got what I wanted. So we're going to do 4.1 subtract 4.2 over 0.122 to give me what I want here. So 4.1 subtract 4.2 divided by, and I'm actually just going to put in my calculation again that I used in part A here, because I don't want to be in a situation where I have lost a little bit of accuracy. And it's easy enough to do here. I could have stored it in my calculator, would have probably been sensible as well. So I get a value here of negative 0.82245. At this point I'm going to introduce a sketch. So I've got a z value here, 0.82245, which actually it needs to be 2 decimal places to make it really workable. So it's negative, so it's over here somewhere. I'm looking at what's below that, so it's over here. So then I'm going to use symmetry to show, well, actually if I look over here, 0.82, then it's going to be what's greater than that value. But I can't look up that, but I can look up the white area there, so that is relating to the probability that Z is less than 0.82. So that I can look up in my table, and I get 0.7939. So then I can do the probability that I'm actually interested in, which is that Z is less than negative 0.82, is 1 subtract that, which is 0.2061. So let's link that back to what we've actually done. So that probability was equal to this, which was equal to this, which was equal to this, which we got from the transformation formula. So to actually answer the question, what percentage of ball bearings are rejected, so this many are below the required amount, this proportion, the same proportion are greater than that, so 0.2061 multiplied by 2 gives me an answer of 0.4122. So we've got here actually quite a large percentage, 41.22%, therefore are rejected.